Okay, well. Just gotta wait for people to join in, and hopefully we can start. So, yeah. Alright, it's already 4 minutes. Gotta wait for another 1 minute and we're going to start already. Cross platform. All right, I think let's get going. All right, so let's start at this point. All right, let's just get going. Let's get going already. All righty. Okay, let's start the project. ZigX11. Okay. mkdir zig vk zig vk. All right, so I'm going to try to do it as quickly as possible. All right, hold on a second. Okay, cool. All right, well, zig init-exe. And now we're just gonna make sure to link with, I'm not gonna bother with dependencies right now. So if you are on Windows, you probably have to do some extra steps to make this work. But on Linux, if you have SDL2 installed, you just say exe.link system library, SDL2. This just makes everything much easier. But surely later on, when we have something working, hopefully we can basically make it better. But for now, there you go. So we just link the system library, and since SDL and Vulkan are part of my system stuff, they're installed on my system using packages. Like you could install Vulkan Devil, which is basically a group of packages for Vulkan development in Arch Linux and stuff like that. But anyways, so const c is equal to c import. There you go, and here c include SDL2/SDL.h you also need SDL2 / SDL vulkan.h. Let's go. And then finally you need vulkan. And for vulkan, you gotta say this vulkan.h. There you go. Now I'd like to, just as a preference, to actually include vulkan first, then SDL, honestly. And also I gotta define one thing, because I'm not gonna be linking to the statically linking to the vulkan loader. I'm going to actually load in the function pointers myself for performance reasons, etc., etc. So I have to actually define vk no prototypes. Okay, not sure why I done that, but anyways. So prototypes, vk no prototypes. Hopefully I spelled that right. Prototypes. And here I just like to do that. I don't want to define it to any particular value, just define it basically. Let me make sure that's the right one. vk no prototypes. There you go. So just make sure it's this one. And that would make sure to only include the function pointer types, not the actual functions, pretty much. And that's pretty much it. That's all we need, I think. And yeah, so that's pretty much it for that one. Now, right now we have imported SDL and vulkan pretty much. We didn't need any particular crazy stuff right now. Okay, cool. So let's get going. All right, so if c.sdl init, c.sdl init video. Okay, cool. Now if that's equal to 0, that means not equal to 0, sorry. And if that's the case, then we're going to actually SDL log error, c.sdl category application. There you go. And then the format is, well, s, and then c.sdl get error. And let's go. That would take care of logging for whatever platform, even if we are on Android or whatever. It's gonna make sure to basically log to the best place it can do. So so yeah, pretty much that's it for that one. Now return error dot SDL init video. Okay, that's pretty much it for that one. Next up, pretty much a similar thing, I guess, but vulkan Lloyd, I think, something like that. Vulkan Lloyd library, and in fact the parameter would be null, and it's basically just like that. Here I'm gonna say SDL vulkan Lloyd library, and there you go, we're done. So right now we're basically loading the SDL the vulkan library from the system, and of course let's not forget to defer c.sdl quit. Oops, oopsies. There you go. Defer c.sdl vulkan in Lloyd library. There you go. Now let's create the window. Let's create the window. Okay, const window is equal to c.sdl create window. The title is salam, which means hello and peace in Arabic, and just a little bit of sprinkles of creativity there. And for the X, I don't care, and I really recommend to just tell it undefined, because some platforms don't like you to control their windows, their window position, sorry. And here the width and height, whatever. And then here make sure to add window vulkan, because we're going to be using it with vulkan. And one other thing that I particularly like to add is hidden flag. Why? Too simply because I only want to show my window when I'm ready to actually render to it. Otherwise the user will just see, you know, like either garbage window while you're still setting up your vulkan context, etc., or there see some other crazy stuff. So I'd rather basically hide it while like at the start, and then basically explicitly show it later on, like this. Show window. That's as basic as that. Of course, you got to do some error checking here. So if window is equal to null, then we got to do some stuff. Basically, similar thing there. SDL log error. Now here, SDL create window. And there you go. And honestly, okay, so that's pretty much it, I believe. Yeah, now let's create the actual main loop. I'm going to label that as main loop, and here we're going to basically create the input loop. So while c.sdl pull event, there you go, and while that is equal to c.sdl true, then we're going to actually process that event that we have pulled. And of course this needs a const SDL event. And by the way, welcome to the live stream, MYD. Welcome. Event c.sdl event equal and defined. All right, let's give it the address to the event so we can put the event there. And since it's gonna put it there, we're gonna make it a variable. There you go. Now we're gonna switch on the event.type. Oops, type. There you go. Now if it's c.sdl quit, which gotta change by the way in SDL3, but anyways, and if that's the case, then we're going to say break main loop, and there you go, pretty much. So that's it for that guy. And we do need the label, because if you don't include the label, then it will actually break out of the input loop instead of the main loop. But basically when we get the SDL quit event, we'd like to quit from the whole thing. So okay, other than that, what else? Oh yeah, I forgot one little thing here, is that defer c.sdl destroy window. One thing I'd like to check real quick, I'm not sure if they included such detail or not, but let me grab a tab here. Just gotta check the wiki real quick. If window is null, this function will return immediately after setting the SDL error message to invalid window. Alright, cool. So that's pretty much it, I believe. Let me try this out. Zig build run. And one particular lesson that I learned about Zig when I was implementing one of my previous abandoned projects of Vulkan is the fact that you shouldn't trust Zig debug build. You just shouldn't trust it, because you're gonna keep on writing your program until sometime you're going to try to actually use release mode, and then yay, you got a UB that you have no idea how to fix. But anyways, switch must handle all possibilities. Else, then well, do nothing, I guess. Segmentation fault. What? From now on, really? Okay, let's see what we got. What is the problem? Switch event type. Now, I think I need to basically set up the debugging already. I have a project that I've done that for. So we could figure out what is going on here. So encode the taco image viewer, let's go. Okay, and VS Code, and let's just copy paste. Launch.json, copy. Let's create a launch.json file. Well, let's just do it ourselves, I guess. The VS Code. launch.json, so you can basically debug that stuff is installed but not supported in this environment. I don't care. Instead of Kodotako image viewer, we gotta say zigvk. That's it for that one. And there's also tasks.json, I believe, isn't it? task.json. There you go. Copy that guy, and there you go. Seems all good. Now let me try to debug this up. Oh, why it's called Windows? Oh my god. Maybe that only works on Windows, isn't it? Configure debug type installed but not supported in this environment. Uh-oh. CPP vs debug. Well, that's weird. I think it only works on Windows. I don't know how to deal with it on that guy. But anyway, let's see what's the problem here. I discovered that channel from a Git repo tagged fast. That's interesting. Let me try to actually go ahead and build this. Segmentation fault. Really? Okay. Okay, what if I'd done this? Oh. What? Link system library, SDL2, SDL. Well, what could be the stupid problem? I don't get it. Really? Okay, for some reason SDL init actually segment fault. What the? Really? SDL.h, import std. This is ridiculous. What if I don't link the library? I'm new to Zig. Welcome to the drill. C import failed. libc headers. Oh my god, yeah. I forgot to link the libc library. Okay, so make sure to link libc for this to work. Otherwise, you just get a segmentation fault. What an amazing error. Really amazing error. Okay. And there you go. I got my Salam window. And I could basically quit it and all good to go. All right, nice. So we have set up the window using SDL. And of course, SDL, why I chose SDL over something like GFW? But because it actually works on a lot of platforms, including Android, for example, and Mac OS, etc. While GFW only supports desktop platforms. That's a thing. And second thing is that it also runs on some platforms that I don't even know exist. So that is amazing and could even be ported to consoles, etc. So if you're using SDL, you don't have anything to fear, pretty much. So yeah. All right, so right now we are done with this. Now here we gotta actually start the Vulkan stuff. Okay, let's see how we're gonna do this. Well, const instance, I think, and then, or honestly, I think I'm going to maybe go with kind of like the way WGPU is structured, I think. So let's have a look into some WGPU Rust example. And then I'm basically going to kind of structure my render, I think. I've never done this before, but it should be nice. I'm going to basically inspire from the structure of WGPU to create my own renders kind of thing, you know. But anyway, if we go to where I could find some example, hold on. Examples, let's go. That is WGPU. All right, hello. This example prints output. No. Let's go with the hello triangle. Okay, source C, main.rs. Okay. WGPU instance. Run. Right. Okay, so first of all, you create an instance, then you create a surface, and then you create an adapter. And then of course the device in the queues through the adapter. Okay. All right, let's get that going. Const struct instance, right? Const instance is equal to a struct, right? And then the instance is, well, we're gonna have an init function. The init function would give us all like either an error or this, which is self. Const self is equal to that guy. Okay, cool. All right. So it seems like you just give it default, right? Let me have a look. WGPU instance. Okay, new, get adapter, create surface, cool. And create surface and you give it the window, cool. All right. So let's find out how to create a surface, instance now. So first of all, in fact, we need to get the function pointer to do that. But before that, let's actually create the info that we need. So const create info is equal to c.instance create info. And then in fact here we only need the enabled extensions, pretty much enable extension count and pp. Okay, let me have a look into this, guys. Oh, you need the s type, but the thing is it won't allow you to only give it one of the fields, otherwise you have to use std.mem. Hold on, std.mem.0 init, and then here give it the type, which is in our case instance create info. Cool. Now here what we're going to do is s type is equal to c.vk structure instance create info. There you go. The s type is always important. The other thing is what I care about here is enabled extensions. You need that to actually be able to create surface, etc., and to deal with graphics on Vulkan. So anyway, okay, well, in fact, I need to get the extensions first from SDL. So I'm going to do that. Well, c.sdl Vulkan get extensions, instance extensions. Here you give it the window, SDL window basically, and then you give it p count, of course an address to the count of extensions, so extensions count, and then you give it null here to get the actual count. So var extensions count, it's gotta be u32, okay, and undefined, because we would get the count from this function basically. And seems like we need the window. Oh, interesting. Okay, c.sdl window, oopsies. C.sdl window. Okay, and I think that's pretty much it, isn't it? SDL window. All right, get extension. Now this could fail, so you have to check if it failed or not. So if is equal to c.sdl false, then we're going to basically do something similar to this, copy paste, and here SDL Vulkan get instance, oops, extensions. You could call the error whatever you would like. Yeah, so that's it. Now right now we have to actually allocate some memory for the instance extensions. Well, for that we have to actually get an allocator for ourselves. So const, actually var They call it GPA, but who cares? General purpose allocator. Ooh, well. Okay, so std.heap.general purpose allocator. And I could even put here a verbose log so I could see the allocations that are happening on my program. Other than that, defer general purpose allocator.dinit. Let's go. GPA. Yeah, GPA. Well, right now we need the allocator itself. That allocator. There you go. And that's pretty much it for that one. Now we gotta basically pass it up to here, cd.mem.allocator. And then here we gotta actually do, let's actually do, let's see. And by the way, extensions count, not the extensions themselves. Other than that, we're going to allocate memory right now. So how am I gonna do that? Well, const extensions, I believe. Maybe I need the var though, but we'll see. Now allocator.alloc comtime t is basically comtime t. Get instance extensions. We need this guy, okay? Just copy this guy, and then here the n size. The n would be the extensions count that we got. And yeah, now defer, of course. Well, honestly, air defer or defer. Yeah, defer. Why? Too simply because we don't need the extensions after this, after creating the instance, pretty much. Vulkan would just go ahead and copy it over. But anyways, defer extensions.dealloc or no, allocator.free extensions, and there you go. Now, what else? We basically got to call the same function once again. But this time, instead of null here, you gotta pass in an address to the extensions. So extensions.ptr, the pointer to the extensions basically. And this is gonna be extensions, not extensions count. And there you go, pretty much. Now we got the extensions, hopefully. Next up here, we would pass them up. So we need the, let's see, extension count. I'm just gonna copy this over so I could see it. So the enabled extension count is equal to extensions count, or too simply extensions, right, len, and then enabled, well, pp enabled extension names is equal to extensions.ptr. Okay, cool. Now we got the create info. Now since we got all of this set up and ready for us, we gotta actually load the function pointer to create the instance. So const, in fact I need first of all to get the get instance proc addr function. So after loading the Vulkan library, what we could do, const, let's see, what is it called? Get instance proc addr. Okay, I'm gonna call it that. You could call it whatever you want, and equal to as, I believe, as c.pfn vk get instance proc addr, and then here you would pass in c.sdl Vulkan get instance vk get instance proc addr. Now I guess this could fail, honestly, but I guess I don't care. So yeah, I don't care for now, but let's just add a comment for now. Maybe check if it's null. All right, and now what else? I guess I gotta actually add it there, and then we basically make it that guy, and now I think it should be all good to go. Now here I actually need that guy. I need the get instance proc addr. c dot pfn get instance. There you go. Okay. Honestly, do I? Maybe I don't. You still use Rust or you switch completely to Zig? For my own stuff that I do, Zig is just much better for me and I prefer Zig. But I still do use Rust from time to time. Depends on the project. There's some projects that are better in Rust. There's some other projects that are better in Zig. But I honestly prefer Zig all the way for now. So yeah. SDL Vulkan get instance proc. Let's just remove that for now anyways. Now what else? Now I could basically actually get the function that we need, which is create instance. So get instance proc addr. Here you give it null ptr because we don't have the an instance yet. It's just a global function that we're going to get. And here you call the function, well, vk create instance is the function that I'd like to get, and then I could use that function afterwards. But that would give me an optional, so I gotta actually unwrap it. And now, and oh, by the way, I also gotta actually, let's see, I gotta say as, basically as, and then here it would be, or okay, as c.pfn vk get instance, well, not get instance, vk create instance. Okay, and then here you actually get the real thing there. Alright, cool. Now I could hopefully use that create instance function. Oopsies. And here I should pass in the info. And then I should also, by the way, check if that errors or not, really. But anyway, who cares? Null here for the allocation function pointers, I think. Or you could just pass it in, allocation callbacks. Alright, and then we also need, what else? Let's see. Oopsies. Well, what else? Yeah, right here will actually give me the handle to the instance. Or you could basically tell the instance, right? So var handle, it's gonna be of type c.vk instance. It's gotta be undefined, and there you go. Oh well, create info. Address to create info, there you go. And of course we need the allocation callbacks, which I also gotta have here, which is gonna be c.pfn vk allocation callbacks. Oh, what? Allocation. Oh, not pfn, vk allocation. There you go. Okay, and this gotta be a pointer to them, I think. Yeah, pointer. Let's see, 1 second. Yeah, pointer optional. So here's how to do it. I think like this, like that. Yep, there you go. And that's the allocation callbacks. All right, I think that's it for that one. Now, of course, we need the dnit function. We just gotta go with void. But in fact, we gotta store, of course, the handle here. So let's see, var actually handle, it's gonna be a c.vk instance. And yeah, that's the handle. Next up is, let's see, I also gotta store the allocation callbacks because I gotta need them in the dnit function, I think. Yes. Okay, Otherwise, we could remove the allocation callbacks completely and just say null. But anyways, so that's pretty much it, I believe. Now the thing is, we need to load also another function pointer, which is destroy instance. So how are we gonna do that? Okay, I think in the dinit function, I'm going to basically go ahead and const destroy instance is equal to, let's see, get instance proc addr null vk destroy instance. But honestly, since this could fail, I'm not sure if I'd like to put it in the dinit. Yeah, well, yeah, honestly, let's just do it, I think, in the init function. So, yep. And by the way, this would give us a vk result. So we gotta check if have errored or not. So if the vk result is less than 0, that means it's an error. If it's equal to 0, then it's a vk, well, it's success. If it's greater than 0, it's also a success, but there is some other kind of thing, like for example incomplete or whatever. But here I'm just gonna say if it's greater than or equal, well, if it's less than 0, then we're going to throw an error. So error dot create instance. Well, okay, I think that's pretty much it for that one. Now it's actually load in that proc addr, and of course I gotta pass in the handle this time, and I gotta store it. So destroy instance. Let's see. So that's gotta be c dot. Honestly, I don't know. Do I want to put it there or not? You know what? Let's just do it in the dinit. Who cares? I mean, even if like it errored, like what I'm supposed to do about that? I mean, like really. So for now, I'm just gonna go with that, I think. And of course, I gotta honestly cast it once again. Let's see, where are we casting that guy? There you go. So something like this. There you go. Use if in declared identifier get instance proc addr. Well, right now I gotta store the get instance proc addr. Interesting. Segfault. Yeah, it's waiting to segfault. Let's see. Yeah, I forgot that I would need to honestly like store the get instance proc addr otherwise. But really, I mean, yeah, sure, I guess. What do you think? Should I do that in the init function? Well, get instance proc addr. I mean, yeah, I'm going to need this proc addr anyways later on. So yeah, I just gotta store it right now anyways. So that makes total sense. Now here we get self. I guess a pointer to self or self itself. For now, let's just say self until needed. Otherwise, self.handle and self get instance proc addr and destroy instance and use local constant. Okay, now we gotta basically destroy instance. Here you pass it the pfn vk destroy instance. All right, now destroy instance, and there you go. You gotta pass it the handle, so self.handle, and then you gotta give it the allocation callbacks, and yeah, that's pretty much it. And that's how you actually destroy the instance. So right here I just loaded the function pointer from the dynamic library, then I basically destroyed the instance. There you go, pretty much, I think. There's still some stuff that I have to do some error handling. For example, this destroy instance, I gotta make sure that it's actually not null, but for now I'm just using this guy. Later on I guess I gotta check it up, and I probably gotta do it here too. And now let's try to actually go ahead and really create the thing that we need to create. Okay, so here let's actually say instance, well, const instance is equal to instance dot init. And by the way, I'm only going to, oh well, never mind, anyways, allocator, and then get instance proc addr, and then allocation callbacks I'm gonna go with null. And yeah, pointless discard of local constant. There you go. Now we got the instance defer instance.dinit. Let's go. I think that's pretty much it, maybe. Yeah, probably missed something. Let's see, value of type heap ignored. Oh yeah. So here, let's check if there is some memory leak. So self.debug.assert that, well, we gotta defer this whole thing. Okay, and then let's make sure that this is equal to okay, otherwise we have a memory leak. Let's see. Okay, expected type, that guy, call confound any opaque. So yeah, I forgot one little thing, which I believe is ptr cast. So yep. Isn't it? Parameter of opaque type is not allowed. Oh yeah, this should be an address or whatever. Cannot convert optional to payload type. Yep. So let's actually go ahead and say window, or you know what, just make it optional, who cares. Zig build run, consider using try catch or if. Yeah, allocator.alloc try, because that could fail, of course. And what is the other thing? Cannot call optional type. Cannot call optional type. Get instance proc addr. Well, interesting. I could strip out the optional, but child. Let's see, cd.meta.child. Okay, bruh. Expected type const fn. Get instance proc addr. Oh no, that's not it really. Honestly, for now, keep it like that. And then what's I'm gonna do? Nah, that's not gonna work out. I need to basically remove the optional from that guy. Well. Okay, well, I guess I gotta do some helper function. And I think I've done that before, really. Yeah, I've done it in my previous project, really. Hold on a second. GitHub. And Zig. It's either this one or the other one. Do not really remember. Oh, not this one. Bruh. Vulkan Zig. Well, I guess this one. Come on. Main.zig. And there you go. std.meta.child. I mean, yeah, that should work, I guess. Yeah. Weird. Dot child. Let's try it again. And now let's make sure in the init function that get instance proc.addr is not optional. Where is it? Yeah. Cannot represent all possible unsigned 64-bit values. Expected type U32, found EU size. What's this? Oh, 0 in it. Oh, I see where what's happening here. Okay, interesting. Let's go back to extensions.len. There you go. So this should be, I guess, as, and here U32. Expected type U32, found U size. Oh well, I gotta cast it, int cast. Did I miss something else? Get instance extensions. Oh, I think this should be U size. Right. Oh, cint. Yeah, cint. Maybe cuint though. Yeah, cuint. Weird. Like, is this doesn't end or what? Cannot cast into pointer type child. Create instance. Oh yeah, I forgot. We need that stupid BDR cast real quick. Hold on. Okay, as BDR cast. I need to make a helper function for that one. I think same thing here. And of course, right now we gotta return the actual thing. Okay, cool. So right now return dot. Then here we gotta say dot handle is equal to handle allocation callbacks. Well, is equal to allocation callbacks, and get instance proc.addr is equal to get instance proc.addr. Right? Oh yeah, we gotta actually try this out. Hello Travis, welcome back to the live stream. Consider using or else or if. Yeah, gotcha. Yeah, I just remembered that that stuff that I gotta do. How's the renderer going? Yeah, just still trying to figure the instance. So zig build run. And there you go, finally it compiled without an error. And yeah, and since I said verbose log, there you go, we got small alloc 16 bytes. So pretty much what I'm doing here is basically retrying this kind of project right here that I've done earlier, but this time I gotta be careful about release mode first of all, otherwise I would fall into segmentation fault and I would not know what's the problem. And second of all, I have more knowledge about how to really structure, like how some Vulkan stuff works in cross-platform manner. So yeah, pretty much. Oh, nice editor. Which editor? Okay. Now I gotta add some stuff here. Okay, there's a lot going on here. Let's see. So honestly, I should probably check out all the errors pretty good, otherwise we can have some problems. So for example, SDL Vulkan Gate instance. Let me check the wiki. Sorry, the documentation. Sorry, bad joke that the SDL black window looks like your editor. Oh, I see. If necessary, use SDL Lloyd library. Returns a pointer to the vacate instance proc ADDR, which can be used to load Vulkan function pointers at runtime. This should be called after either calling this function is available, but it's not saying if das could fail or not. Yeah, it doesn't seem like. What else? There is also not sure. It's not saying much though. But anyways, well. Okay. Well, I think first of all, let's try to maybe take these extensions into its own function, I believe. And the other thing though, also this kind of Lloyd function pointer. Okay, let's actually make its own function. How or where? If in get extensions, get required extensions, void. Now let's actually get all of this stuff and put it here. Now this of course would return a slice, I think, of these guys. Okay. And of course it needs the window though. So window. And it also needs an allocator. cd.mem.allocator. Okay, so that's all it needs. Well, since that's the case, I think I should probably make a struct for the window by itself, really. Yeah. Struct window is equal to, well, what I'm doing. Const window is equal to struct. This is equal, well, equal to self is equal to this. There you go. And then we need an init function which is going to give either an error or self, and also dinit void, and then I'm going to put that required extensions there, honestly. So yeah, now we could just say self, but of course I gotta make sure to say handle c.sdl window. It's gotta be a pointer. Now self window, well, that's gotta be self instead, so self.handle, and then finally self.handle here. And here we could give a more better error here. So error honestly, just keep it for now. Okay. Now in the init function, you need to say this guy, and the init function we gotta say this guy. Oops, and of course we need self. There you go. And here self.handle. And there you go. There you go. Cool. So now, hopefully, instead of getting this SDL window, we could basically get the window itself. And then to simply now remove all this craziness from here. But I need to get the extensions, of course. So extensions is equal to window dot get required extensions. Oopsies, what it needed, an allocator. Okay, let's give it the allocator. Honestly, instead of passing in an allocator and the window, why not passing just the extensions? Yeah, honestly, that's right, isn't it? Well, I mean, I guess so. Yeah, extensions. So what it returns, hold on, where's get required extensions? There you go. That could error, right? And I need this guy. Okay. And now I don't actually need this. There you go. I think that's pretty much it, maybe. Init. Get instance proc ADDR. And allocation callbacks. Now here const extensions is equal to, well, here in fact, here I gotta get the title, and I also gotta get the width and the height. That's the only interesting ones for me here. So yeah, title, which is gonna be well, let's see what it needs. It needs this guy, and then the width and the height I think are cints. Yep, width cint and height cint. I guess that's all we need there. Okay, so let's actually create a window here. So const window is equal to window dot init title width and height, much cleaner. And there you go. Now the extensions are window dot get instance extensions, or get required extensions, I guess. Or why not call it get instance extensions instead? Where is it? Where is it? Where is it? There you go. Of course, try this up. And now in the init, instead of passing in the window and the allocator, you just pass in the extensions. Which honestly makes sense. Yep. So yeah, I think so. And of course, defer. Yep, cleaning up, refactoring a bit there, because it's much crazier than I thought. Defer window.dinit. There you go. So we got the window extensions. Cool. So expected type found. Ooh, what? Oh, why added that guy there? Okay. Yeah, return this handle is equal to I guess to handle, right? And then let's call this handle honestly. And there you go. What's going on? Oh yeah, dot handle. Add a semicolon there. And there you go. Yep. And zig build run. All right, let's see. Expected type. Well, in fact, we just gotta say this. No member, no field or member function name get instance extensions. Did I misspelled it or something? Oh, I gotta try this. Member function expected one argument found 0. Which argument you're talking about? What? Maybe it needs a pointer or what? Oh, the allocator. Yeah. So let's pass in the allocator here. Function with non-void return type info, blah, 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 implicitly returns. Oh yeah, return extensions here. And error defer here instead of defer this time. And since that's the case, we gotta also make sure to do something, which is defer allocator.free extensions. There you go. And let's see, show window. Okay, let's actually create a show in function here. So fn show, which gotta give void, I guess. And here c.sdl show self.handle. Oops. And then here self SDL window, isn't it? No. Self, right, there you go. Let's go. Now of course in here You gotta say window.show now. There you go, much cleaner. Oh my god. Stick build run. And there you go, we got this guy. Boop. And let's go. Now let's make sure that it actually works on release mode. The moment of truth. Release fast. Never ever trust Zig with debug mode. Okay, let's see. It's still going for some reason. There you go. Okay. So it's working. Amazing. Perfect. Nice. So it seems like there is just no way other than really going ahead and trying to, you know, simplify this into structs, really. So yeah, pretty much. So what we have done so far, we have got the instance proc ADDR there, got the window. We should probably simplify this down a bit. SDL Vulkan Lloyd library, get instance proc ADDR, try window.init, extensions, allocator free, and oh, let's actually run the Vulkan configurator. Well, let's call it vkconfig. Well, no, hold on. I'm going to launch it in another terminal. There you go. So let's make the API dump and let's see if that actually works. And there you go. So as you can see, we're calling the vkcreate instance function. It's returning vk success. We're setting the structure type right, nice, and other stuff just zeros or nulls. And the enabled extension count is 2. The enabled extension names is vkchar surface, which is correct, and then vkchar xlib surface, which is also correct. Now it seems like SDL is actually using xlib instead of xcb, but that doesn't really matter. That doesn't really matter. So yeah, pretty much. Yeah, we got it correctly right now. Cool. Now what's next? What's next? I'd like to simplify this further. Okay, where should we start? I think SDL maybe. I'm not sure what to call it. I guess we'll just go with SDL maybe. Yeah, I guess so. Const SDL, well, equal to struct. Okay, and then fn init, and then this would return basically either an error or SDL, and then the init void. Now init would basically do this stuff. Alright, if c.sdl init blah 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 blah, log error, return error SDL init video, otherwise dinit, and dinit would basically do this, c.sdl quit. And with that we could basically say const SDL is equal to SDL.init defer SDL.dinit. Let's go. Of course, try this out because it could fail. And yeah. Yep, we need to return, well, in fact, nothing. Really, yeah. Okay. So const self is equal to this. In used function parameter. I mean, yeah, it would be in used for now at least, since we're using SDL, which uses global stuff. But later on it may not be. Who knows? We'll see. And there you go. It works perfectly. Cool. So that's SDL out of the way. Now the Vulkan library. Okay, so const vulkan library equal to struct. Same thing, const self equal this. And now fn init the init. Honestly, I gotta actually create a little bit of a macro. Or should I say, I'm not sure what it's called. I forgot what it's called, but anyway. So init. In fact, by the way, we don't need SDL there. Self. Same thing here, self. And what's next? Okay, so right now I just gotta actually use this instead. And there you go. Now we gotta also use this instead. There you go. Nice. And there you go. Lloyd library in Lloyd library. Alright, cool. Now we can basically take this out of the way. And now we could just say const vulkan library is equal to try vulkan library dot init defer vulkan library dot dinit. And there you go. Now get instance proc addr could be here basically. Fn get instance proc self void, and then I'm basically going to return this craziness. But let's see how we're gonna deal with this. Now it would be std.meta.child c.pfn vk get instance proc addr. So we could basically remove the optional there, but it could error too simply, I think. Yeah. So why? Well, too simply, so we could do something like this. I'm going to first of all get the proc. So const proc is equal to this. Actually, you know what? If I'm going to say if this, and then we're going to capture the proc, and then we're basically going to return this. Let's see, vk pfn. Now we don't need the as anymore, I think, but I guess we do need the pdr cast maybe. Yes, I think so. Actually we do, right? So we can remove the optional, isn't it? Well, let's just go step by step. So we have the proc here, which is going to be any opaque. Cool. So can we do just this? pdr cast proc. Yeah, self. Do we really need self? Not really, but we just gotta keep it there anyways. Get instance proc. Now we could too simply say const get instance proc addr, or I could just do it directly really. Here, try vulkan library get instance proc. As basic as that, hopefully. And now let's try this out. Did I miss anything? I don't think. Well, get instance proc. Control flow reaches end of body here. Oh yeah, gotcha. Well, else we gotta basically return an error. Error.sdl for now. Vulkan get it vk. Well, I'm just going to copy this guy anyway. Very creative name indeed. I'm going to change those later. I just don't want to think too much about names right now. Otherwise, I'm just going to go into choice paralysis. Okay, so that seems to work. Nice. Right now, we're making sure to handle to make sure that the actual instance proc addr is actually valid, which is amazing. Cool. So now we're good to go, I think. We could also abstract this away a bit. But before that, let's see what else we have here. Get instance extensions, nice. Okay, the instance. So we're creating the create info, 0 init, nice, cool. Create instance. Okay, so vacate create instance. All right, cool. Well, honestly, I think I'm going to actually pass in the library. And then I could basically tell the library to give me some procedure. For example, vacate create instance or whatever, I think. Isn't it? Yeah, honestly, I think so. That's what I'm going to do. So let's remove this guy. Let's actually get the library, the Vulkan library. Vulkan library, let's go. And now here, hopefully, we could choose simply Ilyas. Yes, that's my name. Right, create instance. Hello, Marty Flowers. Welcome back to the live stream. Get instance proc ADDR. Okay, Vulkan library. I think I'd like to say git proc, for example, and then I could maybe say vacate or pfn vacate instance. Create instance, for example. And then here I have to basically give it the actual name of the function. Unless maybe if I can basically do some reflection on this guy, on the type, and to simply remove the pfn and then get the name for out of that. But yeah, but let's start here. I think let's start here, and I guess that maybe could fail. So pretty much right, get proc. Okay, cool. And so we do not need get instance proc ADDR. We could basically get the, so instead of storing that, we could store the Vulkan library, isn't it? Vulkan library. Oops. And so here, in the same way, I could say, oh, interesting. Destroy instance. The thing is, I wouldn't like to actually throw an error from the init function. So what I'm going to do, I guess, is if let's see, if self.vulkanlibrary.getProc, let's say, and then c.pfn vacate destroy instance, vacate destroy instance proc, then basically use that to destroy it. Otherwise we have a problem there. But yeah, I cannot really do much there. So yeah, self.vulkanlibrary.getProc destroy instance proc self.handle self.allocation callbacks, isn't it? So yeah, let's actually implement this guy, this getProc function in the Vulkan library. So, well, since that's the case, honestly, in fact, instead of getting the instance proc, why not get it at the start, basically, and then to simply use that every time? Yep, honestly, let's go ahead and do that. So you don't even need this anymore. So after loading the library, we could load in the proc address. Okay, get instance proc ADDR, and here we gotta use a cd.meta.child c.pfn vk get instance proc ADDR. Let's go. And now if c.sdl vulkan get instance proc ADDR, if we got the proc, then we're going to say okay, then we're going to return that guy dot get instance proc oopsies get instance proc ADDR. myd push to git. Yeah, I'll sure set up the git repo, but before that I'd like to basically finish up with the instance and trying to clean this up, because I'm trying to figure out like what patterns would work for our project to make things easier on the other stuff that we're going to create next, so I don't have to abandon the project at some point. I'd like to basically clean it right now before later on where we have all sorts of craziness going on, and hopefully try to figure out some patterns that would make our job easier, much easier and much more robust basically. So yeah, that's pretty much why I'm taking the time to basically clean this up, so I could figure it out right now before later on where like the project is just tangled up and a mess basically. So yeah, pretty much. So once I basically make sure that I'm good with this kind of design of the instance and stuff like that, I'm going to basically commit it to Git, and then we could go further with the other stuff pretty much. So yeah, Git instance proc ADDR pdr cast proc. Nice. And I think what else I wanted here? Yeah, git proc. Now it would be more complicated later, fair enough. Yeah, pretty much. Void. Now the nice thing about Vulkan is that you only have to basically do a lot of crazy stuff at the start, but then later it becomes quite simple. Like after you get a triangle going, at that point it's kind of a little bit much easier to deal with stuff. But anyways, git proc. But until then it's quite hard to get it going. Okay, git proc. Now we would get the type, so you will get comp time t type, or let's call it pfn. I guess it's just gotta be a type, I guess. Now one thing that I'd like to know, can we actually get the name of the type? No, yeah, I've tried to do that before, but I kind of failed at that, so no. And then we need the name. Why? Too simply because instead of giving me the actual name of that type in the struct, it would actually give me the name of the function pointer type, which is not what we need. Anyways, so the name is well pfn vk get instance proc ADDR. Let's see the name here. It's this guy. C const u8. So it's basically a C string. And now we could basically say const proc get instance. Sorry, we need the self, then self dot get instance proc. There you go, ADDR. And then we're basically going to say name here. But before that, you need the instance kind of. Let's see, instance. Okay. So let's grab the instance. So it's vk instance, okay. But it could be, I may change this later, but anyway. C.vacate instance. But this should be optional, I guess. No? I don't know. And then here the instance, basically. Yeah, it should probably be optional, really. But yeah, anyways. Now, if proc, well, basically, if this guy, then we're going to return it. Oops. Proc. Then we're going to return. Well, here we should return the std.meta.child pfn, isn't it? Yep, pfn, to get rid of the optional. And so we're going to say ptr cast, I think, proc. Maybe. Possibly. What we need also the instance. All right. Let's see how to do this. Where is it? Where is it? Where is it? There you go. Okay. So for this one, we need to pass it the handle. And for the other one here, we need to pass it null. And that maybe should work. No field or member function named getInstance proc in main.vulkan library. Instance init, yeah, we do not need that anymore. In fact, we just gotta pass in the Vulkan library directly, and it would do the rest. Function with non-void return type const. Oh yeah, it's also could error. Else error dot, you know, I don't know what to call it really. Get instance proc addr anyway, I guess. I'll probably change those names later. Okay. Error is ignored. Return. Expected optional type. Found return type error unions. Oh yeah. Try? No, hold on, what? Expected optional type. Oh. I guess I could say basically this const proc and then proc, because I already done that logic of error handling there. But of course, maybe this should be try. Oh yeah, this could fail. Oh, well. Yeah, makes sense. Well, I guess I would just say catch unreachable for now. This is very dangerous in release builds. But I mean, what can I do other than that? I wouldn't like to actually return errors from a dinit function. Okay, seems to be all going fine. On release build even. So yeah, catch unreachable. I'm trying to figure out what could be a good way to do this. We could get the destroy instance here. What do you think, guys? What do you think? How should we go with this? So we got the Vulkan library, we're getting the proc address. of vk destroy instance. Catch unreachable. I would need the Vulkan library later on, so you know you could do catch panic, which will still panic in release modes, right? Oh yeah, that's what I wanted, but I forgot. Don't handle the errors, and just add this. This software isn't for unlucky people to the documentation. That's exactly the case. Right. Oh well. Let's see. Okay, let's actually just do, I guess, destroy instance. Let's store it here, and let's actually get the proc address of that in the init function instead. And how we're gonna do that? Well, std.meta.child c.pfn vk get no, destroy instance. Let's go. Okay, and then self.vulkan library get proc. So we're basically going to do that there, and here I'm just going to say self.destroy instance. And now here I'm going to say destroy instance is equal to this guy. Vulkan library dot get proc. And here is the handle. And of course we got to try this out. And there you go. Great. And I'm storing the Vulkan library still because I probably need it later. And I'll need it to get the proc ADDR of other stuff, in fact. And here's how to do it. Well, I'm basically going to have a similar function to the proc ADDR of Vulkan library. Kind of a similar thing, but... So it would take a type. Well, we already have self, so we don't need this guy. And yeah, std.meta.child pfn or error. Right, cool. Now, what we gotta say, const proc is equal to self.vulkanlibrary.get proc. Here we're gonna pass in the pfn as it is, the pfn, and here we gotta pass in the instance, which is self.handle, and then here name, which we already got, and yeah, try, I guess. Yes, try. And then basically we're gonna say return proc. Return this guy, basically. And yeah, pretty much. Nice. Okay, so I'm not gonna go crazy about creating a struct for every object, Vulkan object. That's gonna take forever. And I think that was one of the reasons I abandoned the last project, because it just took forever to. But what I'm gonna do, I'm going to try to inspire from the structure of WGPU, as I said before. So yeah, we're gonna have an instance, you're gonna have an adapter, etc., etc. So we kind of like going to implement the spec of WGPU in some sense, although I'm not gonna be, I'm just gonna be inspiring from it, but I'm not gonna stick to it though. But yeah, pretty much. So I think I'm pretty good till now. We got init, Vulkan library extensions, great. Yeah, I think I'm all good at this point. I'm gonna need such function like a lot. Maybe I'm gonna make it into a helper. Get proc. vk create instance, much better. Much better. Yeah, I think right now we're ready to get to the next stage, which is the surface, I think. isn't it? Yep, I think so. Let's get going. As you can see, this code is much clearer right now. You got the SDL, you got Vulkan library, window, extensions, instance. Oh, I forgot about this one. Should we do something about it? Let's see. I guess SDL would help here, the SDL struct. Let's see, like how I can do it. Okay, I think we could have basically a main loop like this while true, sure. And then what we could do, maybe var. Now instead of var event, maybe while SDL.poll event basically. And yeah, it would actually give us the event. And then we could switch on the event type. Yep. That looks amazing to me. What do you think? What do you think? Okay, let's actually try to do that. So let's go to SDL. Here, fn poll event. Poll event, and this would actually return for you an SDL event, isn't it? SDL event. Otherwise it wouldn't, I guess, so it's got to be optional maybe. Yeah, and then here we're going to basically say c.sdl poll event, and then here the event. Okay. Right, const actually var event c.sdl event equal undefined, and then we're going to return event, isn't it? Now of course, if that's true, if equal to c.sdl true, then that's gotta be the case. We gotta return the event, else we're going to return null. I think so. I think that's good. Yep, I think so. So right now, instead of that monstrosity that we have here, what we could do, let's remove this guy, and let's remove this. And now I could say SDL.poll event. And let's actually make sure we're naming this right. Then here we get the event basically. Isn't that right? Poll event is not a member function. Yeah, I gotta add the self there. An imaginary self, although we're not using that. At least not yet. And there you go. Works. And thanks to Zig design and thanks to Zig captures, etc., we have a much cleaner interface. Poll event, event, switch event.type, c.sdl quit, break, main loop, else. There you go. Pretty cool. So now let's go with the surface. Yeah. So let's go with the surface now. Struct surface. Const surface is equal to a struct if in init. So either that or self. Const self is equal to this, and of course a dinit function. Cool. Now in the init function, what we gotta do now, the surface I think would basically have both the actual surface and the swap chain, the frame buffers, etc., not just the Vulkan surface. just like WGPU basically. Okay, cool. Let's see. fn init dinit. Now here we gotta use actually SDL to do this. SDL. So c.sdl vulkan create surface. There you go. You need to give it the window. Oops. The instance. The instance, vk instance. Okay. So basically instance.handle. And then the surface, it would give it to you. Handle. So const, actually var handle is gonna be c.vk surface is equal to undefined. And there you go. Now of course we gotta need the window. Oopsies. There you go. And here of course window.handle. And here instance.handle. We also gonna need the instance. But thinking about that, well, init window. Okay, cool. Instance. Yep, cool. All right, now could this fail? I think so. SDL bool, there you go. So if that is equal to c.sdl true, then we could basically return, let's see, dot handle, I guess, yeah. So handle is vk dot surface, well, c dot vk surface. Then here return dot handle is equal to handle. Let's go. Else we're going to return, return error dot SDL vulkan create surface. Okay, cool. And that's pretty much it, I believe. Otherwise, honestly, why not do it like this? SDL false. Here just return the error. And at the end of the day, return that guy. Yeah. Alright, cool. Cool. So that's the surface. Now how do you actually destroy a surface? Well, for that we're gonna need the instance. And well, let's actually store the window in the instance because we're gonna need them, I think. And in fact, I would load the function pointers I think I need in the initialize function, maybe. Yeah, I guess so. Okay, so dot destroy surface or whatever, destroy surface is equal to instance dot get proc. Here c dot pfn vk get destroy surface khr, and here the name is, well, vk destroy surface khr. Too simply. Destroy surface is basically std.meta.child c.no. Yeah, pfn vk destroy surface khr. Nice. Okay, now here I could just simply say self dot destroy surface self.handle, I think, and then self.allocation callbacks. But the problem though with this is that currently SDL doesn't really give you control over the allocation callbacks. It just sets it to null. So for now, we're just gonna set it to null too. So yeah, but it's probably gonna be addressed in the next, like in SDL3, but we'll see. Anyway, destroy surface. Yeah, I think that's all good to go. Now let's try to create a surface. Now, one thing that we have to be mindful of is that in Android, you have to create the surface until you get a particular event, and you actually have to recreate it when you get another event. But on desktop, you do not. Like you can just create the surface once, and there you go. It will always be valid for its whole lifetime. So I'm gonna make the surface optional, like this. Equal to null, right? Okay, now if honestly, let's create a label, I think here, I guess surface. Okay, and then basically here I'm going to say, let's see, if std are built in, do not, hold on, if we go to documentation, zig docs, not that, zig std. Okay, let's look for target, built-in.target. There you go. So it's inside built-in. So we gotta check which target we are in currently. Const built-in is equal to import built-in. There you go. Let's go. I should split this into files, but anyway, where is it? Okay, so if built-in dot target, yeah, built-in dot target dot tag name, I think. No. OS. Yeah, the OS. Okay. So target, let's go back. OS, and there you go, tag. And the tag, this is all the tags that we could use. But what I'm gonna do, if tag, in fact, let's use a switch though, I think. Yeah, let's use a switch. So built-in dot os dot tag. Oopsies. There you go. And now if it's Android, where is Android? Bro, what? Ananas? What? There's ananas, but there's no Android? What are you talking about? Bro, what the? There's all these platforms, but there's no Android. Like, what? Really? Or maybe Android is considered to be Linux? What? Zig check for Android. Really? Yeah, I don't think he's using that here. Well. What? That's weird. I guess let me try to ask the question in the server real quick. New post. Or you know what? You know what? Let's just use SDL for that, really. Let's use SDL. Okay, let's use SDL for that. Oh my god, that's so big. Let's see. Built-in, remove that. I don't need that anymore. And let's go down. Switch. Now switch c.sdl get platform name. That's why it's good to have something like SDL on your side for any cross-platform stuff. Nice. Now we're gonna check if, okay, hold on, if std.mem.eql com type is u8, I believe. SDL get platform, B is, well, Android, I think. I guess it's like this, maybe. There you go. Nice. Now if that's the case, I guess we could return or break surface. No. Is that how it could work? Expected after declaration. Yeah, I think maybe I have to actually put it in a block by itself. Alright, so surface, if std.mem equal get platform Android break surface null. Otherwise, we gotta actually create this surface at this point. How are we gonna do that? Let's see. Yeah, surface dot init window and then the instance. There you go. And of course, break surface right, isn't it? So if it's Android, we're going to return null. If it's other platforms, we're going to basically create the surface at that point. Okay, let's try that out, I think. And of course, defer if surface. And also I'm gonna say maybe surface. Maybe. We get the actual surface. Oops. There you can basically say surface.dinit. Let's try this out. Bitcast size mismatch. Destination type const u8 has 128 bits. The source type const u8 has 64 bits. What? Really? Well, I guess I gotta use, then I'm not sure what it's talking about. So maybe I just gotta use strcpy. Okay. Oh, not strcmp. You can use mem slice 2 on the C pointer to convert this to zig slice. Mem slice 2. Good idea. But honestly, I think I'm just gonna go with this one anyway. So strcmp Android This is why it's important to know C. All right, equal to 0. So because strcmp, if it's equal to 0, that means they're equal. Android. Okay, cool. Let's see what we have there. Root structure file has no member named vk surface. Oh, what? Why didn't actually? Well, anyway, okay. Cannot convert array union to payload type. Consider using try, catch, or if. Oh, try. Expected type main.surface found. Ooh, what? Try. Expected 3 arguments found 2. What? Why? vk allocation callbacks. Well, no, I already got that. vk instance? Interesting. So it actually needs the instance. Cool. Alright, I don't know why that's the case, but okay. Alright, so I gotta start the instance. Great. Okay, instance, vk, well, instance, basically. I gotta say dot instance equal to instance. Okay, here I can say self dot instance dot handle. Yeah, and in fact it did indeed did it. So create xlib surface khr. There you go. Nice, nice, nice. Create instance here and then create xlib surface. Nice. Cool. Now when I actually quit this, it destroys the surface and it destroys the instance. And of course we freeze the memory allocated. Nice. Lovely. So I think that's pretty much it. Now let's actually deal with that application stuff for Android. So here's how to do it. Let's see, c.sdl. I don't really remember the name. Yeah, app will enter well. Actually did enter. Let's go with did enter foreground. Okay, so if that's the case, that means that our app is actually up and running and we're ready to create a surface. So what we gotta do, maybe surface is equal to, well, surface.init window instance, too simply. That's the case there. Otherwise, SDL app will enter background, right? If that's the case, then I'm going to say maybe surface is equal to, actually if maybe surface, so if there is a surface, just in case, if there is no surface, and so if there is a surface, then we're basically going to destroy at that point because it's going to be invalid once the app have entered the background. And if you use it, it's your fault. It will crash the application or whatever. And this is something that you don't find in most, if not all, tutorials out there. They won't tell you about this. And so you may just create your engine, like you go ahead, you create your engine, and oh my god, you just find out that your engine cannot work at all with Android, because first of all you use GFW, which only supports desktop, and second of all you have structured your project in a way that you're kind of assuming that the surface will always be there. So you have to basically restructure your whole project to use SDL and then to handle everything the correct way. And I rarely find people doing it this way. I don't know really. But anyways, maybe surface. So surface then dot dinit at that point. And of course, make sure to say surface equal null, I guess. And there you go. Oh, well, hold on a second. No, maybe surface equal null. So that's pretty much it. Okay, pretty cool. Let's make sure this is still working. Cannot assign to constant. Oh yeah, it is a constant. Well, my bad. All right, var. And honestly, since we're going to make a variable anyways, I kind of forgot about that. I don't really need this kind of trick stuff. I could just say equal null, and then afterwards just say this. So if equal to 0, actually, let's say if not equal to 0, so it's not Android, then we're just going to say that maybe surface is equal to that guy, pretty much. So basically, if it's not Android, then we're going to say maybe surface try surface.init window instance. All right, amazing. Defer if maybe surface then surface.init. Lovely, lovely, lovely. So basically, when we're go out of the scope, we'll check if there is still a surface out there. If there is, then we're going to basically de-init it, basically destroy it. Nice, amazing. We could also try Travis' way, which he said mem.slice2 on the C pointer to convert to zig slice. But the problem with that is that I guess he would have to basically visit the whole string to slice it up, I guess. But let me just try that. Let's see. So mem, I did try to use that before though, but I just kind of forgot at some point. So PDR, here we need to give it, hold on, let me actually put that guy in the comment. There you go. So here we have the pointer, which is get platform, right? And then here we have the end, which is gonna be 0. That's pretty much it, the platform. So that's the platform. Oopsies. Well, const platform is equal to this guy, and then here you could too simply say std dot mem, I guess, dot eql, yeah, u8, and then here you could say now platform, and then here Android. And I guess that should work. Yeah, I should use try here. And there you go, seems all good. Amazing, perfect. Let me make sure that I'm using build release. I don't want to trust debug mode on Zig anymore. I'm not falling for that anymore. Okay, well, there you go. Nice, 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 nice. It works, lovely. Okay, so yeah, I think I'll stick to the Zig way anyways, I think. Thanks, Travis. Okay, pretty cool. Pretty cool. And in fact, we could use SDL here. SDL.getPlatform. And with that, we could go to SDL. Oh, I need a train to actually reach, to navigate my file. Let's see. Fn get platform return. Void, well, that's gotta give you a const u8 there. There you go. Nice, nice, nice. So that's pretty much it. Pretty much it. You get platform there. And now you just say, we could even go ahead and just say get platform if it's Android. And get platform is not a member function. Oh, let's go ahead and fix that. Self, fake self. And there you go. Cool. So right now we have taken care of the surface, I think. Next up would be to actually enumerate physical devices, I believe, and then also enumerate queue families, and basically make sure they support the surface, and also they support graphics. Now for the surface, we have something pretty cool, which is the fact that on Android, if you check out on the Vulkan API, that is something I've learned. Because, you know, like when I knew about this kind of thing that I have to recreate the surface, I was always going crazy about how I'm going to like see if the surface is supported or not. It was really getting jumbled up. But now that I know that on Android, any queue family can support graphics. Can support presentation, right? Can support presentation. So even if the surface is null, we could still just get the physical device. But for other platforms other than Android, iOS, and basically phones, pretty much, like desktop, for example, desktops needs to make sure, you need to make sure that it supports presentation. So that is just perfect. So here we could actually go ahead and try to enumerate physical devices. So for that, we're going to deal with the instance. So the instance, there you go. So fn enumerate instances. Oh, honestly, yeah, let's go ahead and do that. Enumerate instances. Oh, what I'm doing, physical devices. physical, okay, physical devices. Let's go. And this would actually give you a slice, I guess. It would be a slice of vk physical devices. Oh, well, c.vk physical, there you go, cool. Now, vk physical device, okay. It needs an allocator, because we gotta allocate some memory. And yeah, pretty much. Now we gotta use that to enumerate physical devices. How are we gonna do that? Well, let's see. Well, first of all, we gotta get the proc address. To do that, so well, I'm not sure if I'd like to basically get the proc address once at the initialization like I was doing before, or instead and if that's the case, I could probably make it into its own struct, honestly. Well, for now, I guess it's fine, maybe. Well. Anyway, we're just gonna do it for now, just in the normal way. Later on, I may actually, try to see if that would be a good idea or not. Probably it would be a great idea, but for now, let's just do it the easy way. So const enumerate, well, let's just call it proc anyway, equal to what? Equal to try vulkan library. Oh, not vulkan library, try get proc self.get proc. And here we would give it c.pfn vk enumerate physical devices. Oopsies. Devices, right? I guess so. And then here basically I'm going to copy this guy and put it there. And of course I need self. Nice. And now we also need another procedure, which is, let's see, const proc2 proc c.pfn vk well, get q families. Yeah, get physical device q family properties. Ooh, well, get physical device q family properties. That's a big name right there. There you go. So now we got the two proc procedures, or the two functions. And now what to do? Oh, actually I don't need it in this case. Yeah, I only need that one. Yeah, my bad. So right now we gotta say const physical, well, I need actually a var count, okay, var count, which is gonna be a u32 in the find. And then I'm basically going to say if proc, if proc, why it's not auto-completing that stuff? Weird. Anyways, enumerate physical devices. So it needs the instance handle, of course. Oh yeah, gotcha, makes sense. So here we gotta say self.handle, and then here we gotta say count address, then null, basically. Now we gotta check if that is less than 0. If that's the case, that means we have a problem. Okay, so what we gotta do at that point, we gotta return an error. Let's see. I'm just gonna copy that name because I can't think of good names for errors. And gonna put in a count there. And if that doesn't fail, that means we got our count, and then we could basically allocate memory for it. So var allocation is equal to std dot, well, allocator dot alloc, com type is vk physical device, I believe, and then the size is the count, and there you go. Of course, try this out. And then error defer allocator dot free allocation. Allocation. There you go. And if that's all goes well, we actually need to call the procedure once again, passing in the allocation ptr. And there you go. Now it should fill that up. And that's not gonna be the count. And then afterwards, if everything goes well, we're gonna return the allocation, which is the actual physical devices that we got. Amazing. So yeah, pretty much enumerate physical devices. So what we gotta deal with that, or do with that? Well, maybe surface. Okay, Now let's try to get that. Physical devices. Get physical device. Well, instance get physical. Oh, what the? Hold on. Oh, enumerate physical devices. There you go. Here we gotta give it the allocator, of course, and there you go. Now, physical devices. Of course, defer allocator.free physical devices, and there you go. Nice. Cool. Now, can I just debug print that stuff? Hold on. Oh, well. And of course, let me try this out, and then any. Give it the physical device, and let's see if that worked. Expected type, blah, 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 blah. Function cannot return an error. Oh, yeah. Okay. And as you can see, the function is getting called correctly. And then it gave it 1 as the physical device count. 1 physical device. There you go. Now, as you can see, that's pretty much. I think it worked. Yeah. Vacay success. Vacay success. Nice. Perfect. And then, of course, when you quit this, pretty cool. Pretty cool. Everything working out just fine. Lovely. All right. Let me make sure that it also works on debug, because debug have some extra safety checks. So yeah. There you go. Everything all good, pretty much. So we're getting the instances. Now, how the actual WGPU instance works. Let me have a look. Where is the instance? And there you go, new. And there's get adapter and there's create surface. Create surface. Now I could indeed create a little helper function called create surface. Sure, why not, I guess. Let's go ahead and do that, why not? So if in create surface, and then that would basically give you either an error, I guess, or a surface. And then you would return surface.init. And of course you do need the window. There you go, window. So window, and then, oh well, and then the actual instance, which is self, comma, window. And there you go. Now instead of surface init, I could just say instance create surface window. Pretty much just like WGPU basically. Why not? Try. Yeah, pretty much. Right, cool. Let's see if that works. Yep, works just like before. Great, amazing. So what about get adapter, what it does? Get adapter, let's, I guess, look into the source code maybe. Why there's no documentation about that? Weird. Adapter descriptor maybe. Okay, so there is a power preference here. Is that the only thing that you can provide? Power preference, default, low power, or high performance. That's easy to do. Okay. Other than that, what there is to it? Adapter. So when you get to an adapter is basically a physical device, right? Yeah, I think so. And then you create a device from it. Cool. And device descriptor. Fields, extensions. Pretty much. Where's the hello triangle example? So here's what it's doing. So it's creating the surface. Well, of course, it's creating the instance, then the surface, then the adapter. Here, request adapter. It's giving it the adapter options. In this case, power preference, default, force fallback adapter, Did not really remember what it was for. I guess maybe a software implementation or something like that. I don't know. Request an adapter which can render to our surface. There you go, and it's given a compatible surface. So in this case, it's some. But this is just perfect for our use case because, well, this is an option, and we already have the surface as an option. So we're just going to pass the surface directly, basically. So yeah, pretty much. Instance request adapter. Okay, so let's actually create a adapter. Is equal to a struct, and then this, or self, yeah, self. And then I guess we could have like a struct, maybe. We don't really need that right now, I guess. But anyway, fn init, as always, an error or self, and then the init void. Cool. And then init and the init. Now what we need here for now, we need the instance. And here I'm going to have in the instance, going to have fn request adapter. Let's go. Void? No, I mean, this is going to give you an adapter or error. Of course, you're going to give request init instance self dot, well, self, right? And there you go, pretty much. Adapter init self. Lovely. Oh, what? No, that's not how it works. Here we actually gotta do it here. Yeah, so the adapter will be just the handle really to create the device, pretty much, I think. Yeah, we'll see about that later on, but right now here, in fact, this is not how it should work. Here we're actually going to list the all the stuff. Yeah, let's list all the, well, enumerate all the instances. So const physical devices is equal to self dot enumerate what oh, what the, no, not the Vulkan library, the instance. Ooh, what? Okay, enumerate. Oh, what? Well, why that? Why it doesn't show up? Weird. Anyway, ZLS. And then we give it an allocator. We need an allocator. Okay, cd.mem the allocator. Oh, what the? Where is enumerate? Really? Are you kidding? There you go, finally. It's not ZLS this time. This time it's on me, so. Alright. Enumerate physical devices. There you go. Allocator. Try. And then of course the fur physical device, well, allocator.free. And honestly, I think just for safety and for convenience, I think whenever I basically kind of allocate something, maybe I should wrap it into some kind of allocation struct. I think. Maybe. We'll see. But anyway, free physical devices. And there you go. Now we got all the physical devices. Now we're basically going through all the physical devices. Each and every physical device. And we're going to basically, right now, we need to get all the key families for that physical device. Fn get physical device Q families. But there you go, we have the problem that I talked about earlier, because now every time for every single physical device we're going to try to get the proc address once again, which is not very great. So honestly, let's tackle that problem first. I think I'm basically going to have like an instance dispatch kind of struct, like something like maybe this const dispatch equal to a struct maybe, and then I could have like destroy instance here. It's gotta be this guy. There you go. And then what else? Yeah, we're gonna have get enumerate physical devices here. Oops. Yes, and then let's see, c.pfn get physical device q family properties. Oh well. Get physical device q family properties std.meta.child. There you go. Yeah, get physical device key family properties. Oh, I see. Cool. So that's the dispatch basically, and then we could have like an init function for that. Well, let's see, destroy instance, enumerate physical devices. Okay, can we maybe reflect on it and then basically go through all of them? But no, unless if we want to maybe do it like this. Or at least without the vacay, I guess. We could still add the vacay. Yeah, I guess it could be possible to do some reflectance on it using the comp time stuff. Let's see, meta.child pfn. Would that be possible? I guess. Let's see. Either an error or this. Because I cannot use self anymore since, you know. Okay, fn init. There's no need for a dinit function though. Yeah, no need. Okay. Let's see how that could go. So I think I'm going to basically go through the whole thing. Isn't it? We do need the instance. But we need the handle. So, but yeah. Vacate, c.vacate instance. And then basically we gotta go through all the fields. So in line 4. And we're gonna go through this dot fields, but well, type info of this dot fields. Isn't it? Expected loop payload, yeah. Field. And in fact, I do need this to be in defined by default. I guess in defined. In used function parameter. Then I could basically take in var dispatch or self is equal to this dot, well, just this. Cool. And now how are we gonna do it? Now we're going through all the fields of the struct. Now the actual function name, proc name, is vacay ++ field.name, I think. I guess. Vacay ++ field.name. And then the type is equal to field.type. But to be able to use the Vulkan library, I need to add an optional there, I think. Field.type optional. But how? How do you get a type and make it optional? Interesting. std.method.optional. Traits. Not sure how do you take a type and make it optional. Basically the opposite of child. That's basically what we need here. Let's see. How to make a zig type optional? I do not expect to find anything about that. Nope, nothing as always. Yep. Well. I guess let me try to ask the server for that. how to make a type optional. There you go, ask them server. Hopefully someone who knows can actually tell us about it. Let's see, given, for example, U8, turn it into optional U8. But that's gonna take some time, I guess. Meanwhile, let's try to kind of explore the stuff that we have. Fields, global option. Child. Oh yeah, that's what I was using. Okay. Field type, tag. Trailer flags, what? Crazy stuff. Trait. Yeah, no. But I think we could do it. Let me see. Built-in. No, built-in.zig. There you go. Let's look for optional. There you go. Oh, actually it's quite easy to make. Yeah, it's quite easy to make. I think you basically say type, right? And then you give it the info. In our case, it would be someone is already writing on that question. Interesting. But I think we could already figure it out. I think maybe it's optional like this. And then we could say dot child, I guess, is equal to type. Basically field dot type. Right? I think so. Now we got the proc name and the type. Now I could basically use the Vulkan library. Well, in fact, I need the Vulkan library. No, Vulkan library like this, I guess. Cool. Now I could basically say Vulkan library.get proc. Here we need the comp time type, which is this guy. Ooh, there you go. Then we need the instance, which we already have. Oh, yeah, instance. Sorry, not that way. Ooh, well, there you go. And then the name, which is the proc name. Now this could fail, so we gotta say try. And let's go. I think that's pretty much it. So you add vacate to the field name, you get the proc name. And you basically type optional, because get proc is expecting an optional, not just a bare type. And yeah, I think so. Okay, and field. And then we gotta actually assign this to self. So self, well, field, self, self, and then the field name is, well, basically field.name. And then equal to try that guy. I think that should work. Kind of weird, and it would kill, would probably kill the LSB, like ZLS, but yeah. Alright, let's see if this even compiles. It seems like, I guess. Now, what is going on here? I got a weird glitch there, graphical glitch, but anyway. So now, oh my, well, there you go. Okay, cool. So where? Yeah, and the init right here. So instead of create instance. Now after creating the instance, we could too simply, instead of destroy instance here, I could say dispatch, hopefully, is equal to dispatch.init. Here, give it the Vulkan library, I guess. And then here the instance. Well, actually the handle. There you go. And there you go. Now, instead of self dot, well, you have to say self.dispatch. But of course, I gotta say here dispatch. Okay, try, of course. And here self.dispatch destroy instance. Of course, this would become destroy instance like this. Nice. And yeah, I think so. No field named fields in union built-in .type. Oh yeah, I gotta actually say .struct like this. Expected type found type of enum literal. Ooh. Okay, I guess std.builtin.type, isn't it? I guess. Expected type built-in.type. Ooh. Found built-in.type.option. Oh. What? Expected type struct declared here. Really? What do you mean? What? Pubconst struct. Optional. Well, type. Expected type built-in.type. Oh, I think maybe like this instead. Dot optional like this. And then dot child inside of it. isn't it? Expected after statement, what? Why? Weird. Weird. I think the real question here is how to create an optional. How to create optional. No, I mean in a, what is it called? Union, right? So let's have a look into union zig. Alright. Union. So we have a payload union. And then here you just say payload int. Well, that's exactly what I've done, I guess. Weird. std.builtin.type. Very weird. Oh well. How to create a type in Zig. So type dot struct, in my case it's dot optional. Oh, come on, really? You just needed a stupid dot? Really? That's so stupid. Anyways, in line 4. Okay. Now we gotta actually return the self. There you go. Missing struct field, destroy instance. What? Oh well, get remove this guy. And oh my god, I don't know why there's some graphical glitches there. weird stuff. Oh, I guess maybe because I didn't actually destroy the surface yet. But either way, there you go. VK destroy instance is getting called correctly. So I guess I figured it out magically. Nice. And my question is still not answered. But I already figured it out at this point. Interesting. But I'm still interested if there's like an easier way. I mean, but yeah. So as you can see, proc name vk field. Now here I'm creating an optional where the child is field.type, and then here I'm getting the field there. Try vulkan library.get proc. Nice, very nice. Otherwise, though, coming to think about it again, kind of maybe doing double the work. Hold on. If we go to, where is it called? Get proc, there you go. Let's see, 1 second. Get instance proc kddr ptr cast proc. Well, yeah, there's no way to do it other than that. So yeah, pretty much we're all good to go at this point, really. So yeah, cool. Now I could just add functions to here and it would just do the job for me, pretty much. Okay, cool, amazing. Now let's actually use that. So where we're doing, there you go, get proc. So instead of this, remove it. We don't need it anymore. So I'm just gonna say self.dispatch dot enumerate physical devices. Same thing here. And there you go. Sig build run. I guess it would glitch again. There you go. Bro, that's weird. Okay. Nice. Now, let's make sure to actually destroy the surface. How to do that? std.meta.child c.pfn vk, let's see, destroy surface. There you go, equal and defined. Nice. That's destroy surface. Now what we could do, where is the surface? The init self.destroy surface. Yeah, I'm actually doing it right here. Okay, remove that. We already have the instance. Now I could just say self.dispatch .destroy surface. No field name dispatch instruct main.surface. Ooh, well, dot instance. Error get instance proc kddr. Oh yeah, it should be destroy surface khr. Nice. We could maybe try to make a better error there later on. Right now I think it's fine. So destroy surface. And now let's just make sure to add a khr right there. Although honestly I may actually get another dispatch for surfaces and swap chains, like for extensions by their own, I guess, maybe. But yeah. Oh my god, like what? What was even that? Yeah, we're not deinitializing the surface yet for some reason. Why? Destroy instance, but there's no destroy surface. Surface.dinit. Defer if maybe surface surface.dinit. What? Why it's not initializing then? Self.instance handle. Weird. Defer if maybe surface.dinit. Is it really checking for this condition like at that point? Not sure. But what I could do for now, just to test, I could say maybe surface .dinit. Let's find out. And yeah. Okay, you could use, so there is some problem here now. Was not available, trace may be incomplete. Root.main. Attempt to use null value. Oh, maybe surface is null, what? Really? Interesting. Why it is null? Oh, this should be the opposite. So, I guess we're not creating the instance anyways yet? Or what? That's weird. Okay, there you go. And it's still having that stupid problem. I don't know. When I quit my application, it just glitched out. It glitch outs everything. I don't know why that's the case. Weird. Vacate destroy surface gate shard. There you go. We're doing it right at this point. Weird. Okay. So what else? Yeah, let's actually complete that guy. Get platform init. Where is it? Where is it? Where is it? Where we were? I guess let's go to adapt. No, to request. There you go. So here we're enumerating physical devices. Now at this point, let's actually grab the key families. Key family properties is equal to try self dot enumerate, no, dot dispatch, yes, and then enumerate physical, actually get physical device key family properties, and here we could basically pass it the physical device, I guess, isn't it? Maybe also the, let's see, hold on. So it needs the physical device and the queue family properties. What? That's a pointer. Oh yeah, count and yeah, gotcha, makes sense. Makes sense. So where is it? There you go, request adapters. So in fact, let's actually create a function for that one. Okay, so instead of enumerate physical device, now let's go with physical device queue family properties. There you go. So let's actually remove this for now. And it's going to be very, very similar to this one, because it's kind of the same kind of procedure, just a different function though. Get physical device family properties. The only thing that is that it cannot fail, I guess, if I remember. No? Let's see. There it is. Yeah, void. So it cannot fail for some reason. Weird, but there you go. So this one cannot fail. And of course this one too. Now of course let's make sure to change the guy there. And there you go. Just like that. And now it could be either an error. Of course it needs the allocator and self. And c.vacq. Sorry, Q family properties. There you go. Nice. There you go. That's what I'm talking about. Dispatch, give physical device, count. Yep, seems all good. So now we're just gonna say for Q, well, get physical device key family property. Well, in fact, self dot get physical device key family properties, give it the allocator. And now here let's say the value is Q family properties. Ooh. Q family properties. Now too simply we gotta check the, oh well, hold on a second, where is the physical device? It needs a physical device. Well, instead of, yeah, makes sense. So where is it? So instead of self.handle, we need actually the physical device. Right, and here let's actually make sure to get the physical device. C.physical. There you go. That's the physical device right there. Great. Now here, before the allocator, I have to pass in the physical device. And there you go. Now let's make sure that's all going good. But oh, I forgot. I need to make sure to actually deinitialize this guy. So Q families properties. So const Q families properties is equal to that guy. Of course, it could fail. Try. Sorry, and then defer Q family properties. Well, in fact, allocator.free. Q family properties. Let's go. And yeah, let's see if that works. And it's going to glitch my screen again. Okay, well, where's the window though? What? Oh, there you go. Okay. Come on, bro. Why? It wasn't doing that before. I'm not sure why now, but we'll see. Okay. So request adapter. Now let's actually check that Q family properties. Now if Q family, well, it's not giving me autocomplete, seems like. Restart the server. Hopefully that would help. Oh, queue family properties. There you go. Okay, queue flags and queue count. So we gotta check the queue flags. The queue flags. Now in this request adapter, we gotta get an optional surface. Optional surface, just like that. And we gotta, well, actually checking the presentation support would be fun because SDL doesn't have that yet. Actually it does. Yeah, it does, right? Yeah, it does. Well, in fact, not SDL, yeah. Anyway, never mind. So queue flags. So if queue flags and let's see, c.vk queue flags .ol vk queue, how do you do it? I forgot. Queue, I guess graphics or something. There you go, graphics bit. So if that's the case, and also let's see how we're gonna do that. Well, I guess it's called vk get surface or physical device presentation support. Not that. What the? Look at that name. That is crazy. Well, let me actually find the name. I forgot about it. So surface physical device presentation support. Oh, actually that's part of the SDL, right? Yeah, my bad. My bad. So c.sdl present actually Vulkan. Where is it? What? Are you kidding me? Let's have a look into SDL Vulkan. Oh, actually I already have another window open. There you go. SDL Vulkan. How to check the stupid surface? That's so weird. Get physical device surface support. There you go. So it's not on SDL, right? Interesting. To determine whether a queue family of a physical device supports presentation to a given surface, call this guy. You give it the physical device, queue family, surface, and what? Okay, it tells you if it's true or false. Cool. So let's actually get that. And let's load that in. KHR cd.meta.child c.pfn equal to undefined. And there you go. It's right there. Nice. Now let's go back. And here I gotta basically say self.dispatch dot get physical device surface support KHR. And what do you pass to this though? Well, actually I gotta let's actually do it here. So fn give physical device surface support. Or can't I do it maybe in the surface? That would be nice, I guess. Yeah, maybe. Let's go to the surface though. Where is surface? There you go. Get physical or get Q family. Support. Presentation support. Or just get presentation support and call it a day. Get presentation support, as simple as that. Now, this would give you either a Boolean value, but it could also error. So yeah, pretty much. Now what we gotta do, get presentation support. Self-dispatch, get physical device. Now it's gotta be self.instance. Right, .dispatch, get physical device, blah, 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 blah. Okay, cool. So we gotta check this if it's an error or not. So if it's less than 0, that means it's an error. And since I do not have really a great name for it, let's just call it with that. Okay, and then we gotta return, well, let's see. The support is vacable. C.vacable 32 and defined. Why that's what the? Okay, let me see the actual thing again. So we need these guys. There you go. Okay, put it there. So we need the physical device, which we of course gonna get here. Oh, c.vacate physical device. Let's go. And then the key family index, which is gonna be 32. Hold on a second. All right. And yeah. Now we gotta pass in the physical device, and we gotta pass in the key family index, and then we gotta also pass in the surface, which we have here, self.handle, I believe, and then here you give it the address to the Boolean value there. It's a var. Does support. In fact, what they call it, I have no idea. Let's see. They call it p supported. Does support or is supported. Okay, is supported. That's a much better name there. Okay, is supported. Return is supported. Pretty much. Lovely. Less than 0. I think that's it. Is supported. Later on, honestly, maybe I'm going to make some function that would basically, like, you'd basically give it the error, the actual, like, vacate result, and then it could give you back an error. Yeah, that would be amazing. But yeah, for now, this is fine. Found 0. Where is it? What's going on here? Here. Okay, cool. Now let's say surface. Well, do we have a surface, right? Yes. Now, if there is a surface, though, well, and I'm going to say is supported, okay? Is presentation supported, okay? Now, var is presentation supported is equal to this guy. Well, is presentation supported? Oh, sorry, end and is presentation supported. And that, I guess, equal to that. Not sure. Anyway, never mind. Is presentation supported? Use of indeclared identifier. Okay. Actually, const, I think, is equal to surface. Now, if surface, though, if surface. Actually, let's call it var. And then equal to true, I guess. Now, if surface, then what we could say is presentation supported equal to, well, in fact, that would be maybe surface. Maybe surface. And it would give us surface. And then we could use the surface to get the presentation support. And here we gotta pass in the physical device. Well, physical device. And we gotta pass in the key family index. Key family, well, we do not have the key family index. We have to get it, well, comma, 0 point, and or dot dot, comma, index. That's the key family index. And there you go. Lovely. Now, of course, try this out. Now, expected statement found at that. What? Okay, cool. So I think that's it for that one. Now, if this is the case, we're going to return an adapter. Right? Isn't it? An adapter. Let's see. In fact, what is an adapter after all? Hold on. Let me go back to... Where is the WGPU stuff? There you go. In fact, coming to think about it, what is an adapter? I think it's basically like the physical device in the key family, pretty much. Yeah, probably. Key family. Let's see. Where's the example? Yeah, there you go. Okay. Great. I think, yeah, it's pretty much just the... So adapter dots init. Okay, you just give it the instance, which is self. And then I'm going to give it the physical device, I think. And I'm also going to give it, I believe, the Q family. Isn't it? Physical device and Q family. Q family index. I may actually need the Q family properties too. Well, we'll see. Because I probably need that for the... Isn't it? No, I don't. I don't think. Although if I want to do some validation, yeah. Q count. Interesting. So for now, let's just go with this guy. So physical device, Q family index. That is what is an adapter, basically. Just an instance, physical device, Q family index. Pretty cool, I think. So const, well, not const. Here we gotta say instance. That's gonna be the instance, and then also a physical device. vk.physical device. Well, and then c.vacate, and then finally key family index. It's gotta be u32. And that's it, I guess. So I just gotta basically, in fact, I don't even need an init function really, like literally. I do not. And by the way, I need self here. Yeah. Now let's go back to where we're actually creating that adapter thing. Okay. Here, instead of adapter.init and stuff like that, I'm just gonna say adapter. Or in fact, maybe just this guy. Dot instance is equal to self dot physical device equal physical device, and then dot q family index. Ooh, family. Well, q family index. Okay, I think that should work. Maybe, we'll see. Request adapter. Am I using request adapter already or not? I don't need this anymore. So const adapter, I guess, is equal to, well, instance the request adapter. Let's go. You gotta give it an allocator and maybe a surface, which we already have. As I said, just to reiterate, this is perfect in our case. Why? Because in Android, all key families supports presentation, so we don't care. Like, we do not have to check if the key family supports presentation or not. So that's just perfect. And on other platforms, of course, you do. Of course, well, there's iPhone and there's some other platforms that, like Android, doesn't, like, all the key families of them like supports presentation. But anyway, you got the point, I think, hopefully. Okay, so I think we're good to go. Let's see, is presentation supported equal to true? Cool. Cool. Let's check it. Let's check this out. Allocation.ptr. So cannot cast into pointer type child. What? Oh. There you go. Expected type U32 found usize. Yep, I gotta actually cast that. Function return type declared here. Consider using a try. Well, yeah. Found U32. Oh yes. Is equal to, well, c dot vacate true, I guess. There you go. Expected type bool found U32. Yes. So basically, let me try to think about this. So it's basically, so when you end those together, let's see. Q flags and c.vkq fam graphics bit. I guess it should too simply contain this, like just like that. I guess that's how you check for it. Expected type U32 found usize. Again, Same thing. So int cast. Control flow reach ends of body. Yeah. So what happens basically if you do not find any of that? Good to go. Well, at that point, you're just going to return an error. No suitable queue family. There you go. So, okay, let's see what we have done. As you can see, we're getting the physical device key family properties, and we're getting the physical device surface support, which was fake a success, and it is indeed supported. So it basically returned for us the adapter. Perfect. And luckily, right now, it didn't actually did that weird glitch. Okay, amazing. So destroy instance, destroy surface. Lovely. And it's also free in the memory that it allocated. Amazing. Perfect, 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 perfect. So lovely. So I think at this point we're gonna wrap this up, and we're going to continue tomorrow, inshallah. And so yeah, pretty much. Is anyone still on the stream? You probably either slept or I don't know. Interesting stuff. Is there any questions before ending the live stream? And yeah, of course, I'm going to actually publish this into GitHub, but just not now or yet. I'd like to make sure that I'm not abandoning the projects first. Probably not this time, hopefully, but we'll see. I just don't want to litter my GitHub anymore with the abandoned projects. So I'm gonna wait a bit, at least until we get a triangle. So, but we'll see. I may actually publish it and then basically put the link in the comments. So pretty cool. One little thing that I've seen here is, oh well, it's fine anyway. Request adapter. So right now, as you can see, we have finished the surface, the instance, the adapter. Next stream would basically create a device, and with that, we're pretty much done with the context. And of course, we gotta encapsulate all of this stuff into a context, like the instance, the surface, and the adapter. All of those would probably go into context. Not sure though about the surface, probably, but we'll see. But yeah, that was it, I believe, for this live stream. Thank you for tuning in, and see you later. Bye, everyone. Oh, by the way, first of all, hold on. Someone have actually answered my question, I guess. So someone said you could just do optional T. I don't think that would work. I mean, I would hope that was like just it, I guess. Given, for example, any type implicitly cast to its optional variant. So if you have a U8, you can just assign some U8 variable to it. No, that they didn't understand the question, I guess. I don't know. I mean, like really, let me try one little thing, just real quick. Okay, so what happens if you say field.type? Really? Don't tell me that was all. What? Are you kidding me? So that was it? Oh, what the? What happens if I don't make it optional though? There you go, of course, we have an error. So yeah, pretty much. So it seems like you just need to Can't believe I didn't figure that out. Alright. Well, so yeah, that was it for this live stream, and see you later. Goodbye everyone. Thanks for watching. Thanks for tuning in. See you tomorrow.